This video is about differential amplifier and its pspice simulation. Let's first take a look at the schematic of a typical differential amplifier. The input resistance Ri and the feedback resistance Rf. There are two input signals from the negative and positive input pins, input 1 and input 2, respectively. And here's the output signal. A differential amplifier may be working at two different modes, a common mode or a differential mode. In the case of a common mode, the two input signals are equal. And ideally, the output signal is zero. For the differential mode, the two input signals are not the same, and the output signal is related to the difference of the two input signals by a ratio of the feedback resistance over the input resistance, which is Rf over Ri. The following examples will help us better understand the differential amplifier. The first one is the common mode. This is a functional schematic. You can see that the op-amp is properly powered, and both of the input signals are 10 volts. That's the meaning of the common mode. We could simulate the output signal. From the simulation, it can be seen that the output signal has a small magnitude that is very close to zero. The second example is an example of a differential mode. We're still going to use DC signals for both of the inputs. The input from the positive input terminal is 10 volt, while the one from the negative input pin is 9.8. The rest of the circuit stays the same as the previous example. That is, the input resistance is 1 kilo and the feedback resistance is 10 kilo. Simulate the output signal. The simulation result shows a flat line with a magnitude of 2 volt. Think about it. Does this make sense to you? The last example is another example of the differential mode, but instead of the DC signals, a sine wave will be used for one of the inputs, while keeping the rest of the circuit the same as the previous examples. The input signal from the positive pin is designed as a sine wave, with the parameters shown here, and the other input is grounded. So this is a differential mode. For the simulation result, let's show only a couple of cycles. It's always a good practice to double-check the input signal. This is not only true in practice, but also for simulation. Here's the input signal, a beautiful sine wave, 200 millivolt magnitude, and 10 milliseconds per cycle. Let's add another DMM for the output. Okay, now we'll have both the input and output on the same graph. The green one is the input with a magnitude of 200 millivolt, while the red is the output with a magnitude of 2 volt. After you make sure you understand those examples, I have a question for you. So the question is, what's gonna happen if we switch the order of the two inputs? That is to say, the positive input is grounded, and the negative input is the sine wave. Let me reveal the answer for you. The simulation result will look something like this. The magnitude of the signal stays the same, but the input and output will have a phase difference of 180 degrees.